This is another simplification exercise, and so the idea is to simplify this expression, and we're going back to radicals again. So um, in this case, we need to see basically how we can simplify the expression a to the third power with index 2, b to the seventh with index 2, and z to the third with index 2. Um, so we're going to apply a couple of properties here of radicals, and before we move on, to make this easier, we're going to separate it, because sometimes in the process of simplification we get confused and we eliminate the radical, and this is not the case for in every single for this exercise. So whenever there's a property that says that whenever you have a radical and you have two numbers that they multiply each other inside the radical. So in case of multiplication and division, you can apply the same property. Don't get confused because I'm using A and B. I'm just using this to explain a property. So in this case, you can say that since the number are multiplying, so you can separate this into two different radicals with the same index, that they multiply each other. And that way you simplify this expression along with the radical and this expression along with the radical. But once again, this is only applicable for multiplication and division. If you have addition or subtraction, you cannot do it. For example, if you have this a plus b and you have square root of a plus b together, you cannot separate this. This cannot be separated. Okay, this has to stay together. So, but in this case, we are multiplying here and we are multiplying here, so we can apply this property right here. And we're going to apply it, with three different terms. So the square root of a to the third times b to the 7 times c to the third power, we can separate them into three different expressions. This a to the third, the square root of a to the third, times the square root of b to the 7th, times the square root of z to the third power. And now that we have all this separated, now we're going to work with this individually. Okay. Now the idea is this: can I simplify the powers and the index from the radicals? Remember that it was explained before that the radicals and powers, they're inverse to each other, so they can be simplified. Okay. Now you need to see if basically the numbers are divisible by each other. One of them divides the other one, and in this case, the power is greater than the index, because the index, remember, when you don't see the index is number 2. So in this case, you need to see if 3 is divisible by 2, 7 is divisible by 2, and 3 is divisible by 2. And in this case, they're not. So what you do is you look for um, a lower number to the number 3 in this case, but it's the closest one you can find to the number 3 that is divisible by this index right here, which is the number 2. And that way you're able to simplify. So in this case, you have basically the number 2. So we're going to separate a to the third into a to the second times a to the first power. Okay, we're not going to write the number 1 because when the exponent is 1, we don't write it. And then we're going to still keep basically the radical in this case. And then we're going to go back again and apply this property, separate it again, and that makes it a lot easier. Okay, we're going to do exactly the same thing with the b to the 7. So b to the 7, 7 is not divisible by 2, so we find a number that is lower than 7 but still divisible by 2, the closest one that we can. So it's basically 6. So we're going to basically do b to the 6th power times b to the first power. And we're going to keep the radical, which is radical 2 or square root of this expression right here. And lastly, we're going to do the same thing with z to the third power. 3 is not divisible by 2 once again, so the power 3 is not divisible by the index 2. So we find a number that is less than 3, but is still divisible by 2, the closest one to 3 that we can. And in this case, is the number 2. So we're going to write this expression as a z to the second times z to the first power. So you keep the same base. You have the exponent, so it gives you back z to the third, and we're going to keep the square root. Okay, talking about this a little bit, remember, when you multiply two expressions with the same base, that they do have powers, you keep the base and then you add the exponents, and that's why you're able to break this a to the third into a to the second times a to the first, this b to the 7 into b to the 6 times b to the first power. Now we're going to apply again this property right here, and we're going to separate them a little bit more so we can basically make it simpler. to simplify. So we're going to have to, since we're multiplying here, we're going to have the square root of a square root of a to the second. Let me go back here again. Times the square root of a times, we're going to separate this expression right here, the square root of b to the sixth times the square root of b times the square root of z to the second times the square root of z. And now what we do is we simplify what we can, and we cannot simplify, we'll leave it the way it is and see if we can combine them back together. So we're going to simplify this, this, and this, and we're going to leave behind this, this, and this, because these are not simplifiable. 1 is not divisible by 2, 1 is not divisible by 2, and 1 is not divisible by 2. And I mean the power with the index, the power with the index, and the power with the index. So, but this one is simplifiable. So 2 is divisible by 2, so they simplify, and it gives you a to the first power. We're going to keep this one, times the square root of a. This one is simplifiable, so 6 is divisible by 2, so we're going to simplify this and this, but now keep in mind, 6 divided by 2 is equal to 3, so this expression right here is left with the power 3. So from here you get times b to the third power. Times, we're going to leave behind this so far, the square root of b, times, this is simplifiable because you have index 2 and power 2, so 2 divided by 2 is equal to 1, and you have a z to the first power, that's how the 1 is used, times, this cannot be simplified, is square root of z. Now what we're going to do is, we're going to bring together this, this, and this, and we're going to bring together this, this, and this. So we're going to just move the terms around. We're multiplying, so it doesn't matter which order you place them. So this is a times b to the third times z to the first power times the square root of a times the square root of b times the square root of z. Now, these three terms right here, a times b to the third times z to the first, there's nothing you can do with it. But this 3, we're going to apply this property backward now. So we're going to go from here to here now. So if you're multiplying two radicals with the same index, they have to have the same index. You can rewrite the expression using only one radical and multiplying the two radicands. So in this case, this expression, this expression right here, could be combined back under one radical only. So this is a times b to the third times z to the first times a times b times z, all of this is square root, and this is basically your result after you simplify the expression that was given to you at the beginning of a square root of a to the third times b to the 7 times z to the third power.